Cacheaux. I'm a mobile architect at Atlassian. I'm also a tech editor for RayWonderland.com. And I'm super excited today because I get to talk about something I'm really passionate about that I think is something that's really, really important that our industry is kind of going towards the wrong direction. So the whole point of this talk is that writing readable code, it's not easy. We really don't teach it. It's not part of like curriculum at universities. It's not something that gets taught a lot. It's also not very natural. So it's not the kind of thing that you'll get good at just by writing code. You can continuously write code, and it's very hard to actually get better at writing readable code. So what's the big deal? Well, time is money. We spend a lot of time reading. You'll hear me say that over and over again. It's a very important point. But if we get better at writing readable code, it turns into time savings where we can do other things with our lives. Also coding if you like to code. Code is generally very hard to read just by nature. We do code reviews, we fix bugs, we add new features, all kinds of stuff. But when you work with a code base that is readable and it's easy to understand, it's a lot of fun because it's very easy to add features. If something breaks, it's very quick to fix. You're able to deliver faster to your stakeholders. It's just a very fun thing. And it's also fun when you're working with a team and everyone's kind of gelling together. So this talk is not about tabs versus spaces, because that's kind of boring and controversial. This is also not meant to be used for prototypes. So if you're building something you're throwing away, this advice doesn't really apply because there's a lot of time and effort in place to get this stuff rolling. So sit back, enjoy. I've got handouts here at the end with all the resources, so don't worry about having to take notes and stuff like that. And I'll send out the slides here after the talk. All right, let's dive in. So state of affairs. Our industry is in a bit of a conundrum where we're trying to compete with each other and we're trying to get products going faster and faster, and people are pressuring engineers to deliver faster. And it's just kind of a problem because we're under constant pressure to deliver. And I've done it, we've all done it. You write some code, it works, ship it, right? Like it's done, it's ready to go. But there's actually a big difference between solving problems and writing production code. Those are actually two different things. And I think it's just natural to just, when you see something to work to ship it. Another thing is, over time we just get used to it, right? We get used to reading difficult code, and it just stops becoming a problem. And so it's something that, I think that's why it's a problem in our industry, because we're all just used to it by now, right? The other point is, back in the day, compilers were not smart, so we had to be very careful when we were creating variables and how registers were working and stuff like that. But nowadays, compilers are really smart, so we don't have to worry about all these details that we used to worry about. So if someone tells you you can't write readable code because of the compiler, that's BS. And finally, we read a lot of code, right? We read a lot of code. That's where we spend most of our time. So this is from Uncle Bob. He wrote clean code. Indeed, the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. So making it easy to read makes it easy to write. So 10 to 1, that's a lot. It's a lot of time. How many of you guys started a new project, an existing project? You open up Xcode, and you're trying to figure out how this thing works, and this is how it goes. Where's the app delegate? Oh, found it. Okay. Oh my gosh! All this stuff in the app delegate, all these settings, all these things. What's going on? Where's the review controller? It just takes forever, right? Like when you open up a new project, it takes a long time to figure out how things work, and it shouldn't be that way. That really is not the way it should be. Someone somewhere is reading your code right now that you wrote 5 years ago. That can be kind of scary. All right, so that's the state of affairs. So what can we do about it? So I really recommend this book. It's not exactly about writing code. It's about designing products. But if you think about writing code so that someone else can read it, you're designing an experience, right? So there's so much from this book that you can take away with you. Also, you can apply this book to tons of other things, but it's all about humans and how we interact with things and how those interactions can be made better. And so I'm using a lot of the principles from this book throughout the talk. The core thing is that we're complicated, right? We all come from different cultures, different backgrounds, different skill levels. Something that makes sense to you might not make sense to someone else. Language is a very complicated thing. We're writing code in English, right? It's a language, and it's very difficult. And so this topic is a very complicated topic. Our brains love patterns. Our brains are like pattern matching machines. And we can really use this to our advantage when we're writing code. When you're with your teams, putting patterns in place into your code makes a big difference. I know we did this in one of my projects where we figured out how we're going to do all these things, and we're going to do them the same way, and then we grew really large to a large team, and every time someone onboarded, all they had to do was look at the code, and they could like, oh, this is an example of how I do X, Y, Z. Okay, I'm going to do it this way. And we didn't have to like have 5 different architectures, 5 different styles. Got Realm over here, Core Data over here. We've got like RX Swift over here, and all this crazy stuff. You know, we've all been there. Like there's source codes out there that have all these technologies mishmashed because the team isn't rolling together, right? So putting patterns in place is very, very powerful. All right. So let's talk about coding for humans. So the talk is kind of like 3 mini talks, going from high level to low level. I didn't want to enumerate through a bunch of like code formatting and all this other stuff. That's kind of boring. I do have references to point you to that. But what we're going to go over is from project level to architecture to source code. So we're going to go from high level to low level. So let's jump in. So the very first thing is onboarding is a very, very important thing. Because we get new team members, team members leave, come back. You might go away from the project and come back, right? And so it's really important that when you open up a project, it's easy to find things. So one recommendation is to provide a README, a high-level overview of how things are structured, but leave out the details, right? Because the more detailed this is, the harder it is to maintain. I would really treat this README as like the holy grail, and it's part of code review, and it's basically code, because it's very, very important. The kinds of things that can go in your README: how is your stuff organized? Where are these view controllers? Where is the persistence? Where is all this other stuff? What architecture are you using? Hopefully only one, and hopefully it doesn't look like that. Vocabulary: a lot of our products have very specific domain. Are you doing a sports app? Are you doing a health app? Are you doing a social media app? Vocabulary is very, very important, so defining those things up front helps a lot. And any patterns that you put in place, whether it be design patterns or just ways that the team does things, those are very, very helpful. So moving on to organizing source. So organizing source is really important because before you can read code, you have to find it, right? And whenever you're trying to add a new feature or fix a bug, you're always trying to find code, constantly trying to find code. And we tend to not be very good at doing this. So how can we design an experience in Xcode so that it's super easy to find code? A lot of this might seem kind of obvious at the beginning, but there's a lot of like details and a lot of very small things I'm going to point out that make this really awesome. So first thing we want to do is tell a story, right? Tell the user story. The user goes through a journey when they launch the app for the first time, all the way until they delete it, right? Try to follow that story in your code. It's really, really, really helpful. We'll go through an example in a second. Another important thing is to map. So map what your app does into the way you organize source. And we'll go through tons of examples of this, but things between timeline and physical, vertical, horizontal things. We'll go over that. But another really helpful thing is to think of view controllers as packages. Don't think of them as files. This really helps a lot. So this is Uncle Bob. A lot of these ideas are inspired by him, but one of the things that he talks about is screaming architecture. So when you look at a blueprint of a library, it screams library. Like you're like, oh, this is a library. The same thing should happen when you open an Xcode project, right? I should be able to see, this is a sports app. This is a health app. I should be able to see this. I shouldn't have to see view controllers and view models, and like has nothing to do with your domain. So I'll go over an example of this. What we're going to do is we're going to take Twitter, we're going to deconstruct it, and figure out how it would be really nice to organize Twitter in Xcode. So the first thing we're going to take a look at is the user journey. So from the very beginning, you start with the welcome screen. You have the option to sign up or log in, and then you end up in the Twitter app. This is kind of like a timeline of events. So if you think of this timeline, you jump into Xcode, you can do a direct mapping between the timeline of the user journey, which we just saw here, and the way you organize things. This makes it really easy to find things, right? Because welcome, sign up, log in, Twitter, like it's very easy to find stuff. So thinking of like temporal like timeline and organizing like from beginning to end, top to bottom, that really helps a lot. So that's okay, fine. Let's dig a little bit deeper. If you think about view controllers as packages, view controllers are more of groups and less of files. So we'll go over some more architectural things of why this really helps, but it's really nice to group a view controller as a group and put it as the first file, right? And then everything else that's local to that view controller goes inside. All right, here comes the fun part. So we've got the Twitter app, which has a tab bar and a nav bar. One interesting thing is that nav bars are local to the view controller inside the tab. So if you have 5 tabs, each tab has a different nav controller, right? But one thing that's interesting about Twitter is that they've got these 2 navbar items in multiple tabs. So if I'm trying to organize code the way things are laid out in UI, like how do you do that? So we'll look into that. So at a global level, your Twitter app has a navbar and it has a tab bar, right? So we can map that physical reality in Xcode, where we have Twitter, and we have the navbar and we have tabs, right? And these are equivalent in vertical spacing in here. So it's very easy to see what's going on in Xcode. So let's take a look at that navbar. So we've got these 2 navigation bar items that are kind of global. So let's look at how we would map those. So under the global navbar group, we could do search, and compose tweet. Again, the left one is in the top, the right one is in the bottom. I know this sounds like, oh gosh, you're being OCD, but it really makes a difference. Like all this stuff is subconscious to our brain when we're trying to read this stuff, and we know the way that our app is laid out very well. So taking advantage of that knowledge and that subconscious and encoding it into the way we organize things is super powerful. And this is another example of view controllers as packages. Again, so each view controller is kind of a group with all the local files. Cool. So that's kind of the global level. So let's dig one level deeper. So we've got the home tab. How does that work? Or tabs. So you can organize tabs again the same way that we talked about before, left to right, top to bottom, right? Makes it very easy to find things. All right, let's dig into the home tab real quick. So the home tab has a nav bar like all navigation controllers, and it's got a nav stack as well. Stuff we all know. But one cool thing we do is we have a group for the nav bar, another group for the nav stack. And in the nav bar, we've got one nav bar item that navigates to a view controller. So what we can do there is inside the nav bar group, we can have our connect view controller package. Makes it very easy to find things. I'm going to zip through this real quick because this is pretty self-explanatory. In the tweet list, I can drill into any of these tweets, right? And that's just a simple nav controller, nav stack, right? So one thing we can do is we can define that nav stack right in Xcode and put each nav item or nav view controller inside. So it's very easy. Again, we see the tweet list first, so it's top. Then we drill into the tweet detail, that's second. So the ordering really matters. So the two main things that we used to make it really easy to find things is we took a look at temporal, the timeline of how a user uses the app, and we tried to kind of organize our Xcode in that way. And we also took a look at the physical qualities of our UI and try to organize our source that way. So how about reusable code? Because we were just talking about view controller, but like usually the hard part is like reusable code. So what you can do is you can have a whole nother group that is a reusable group, and you can organize it like this. Later in the talk, I'll go over use cases and other interesting things that we can do there. But it's nice to put all your UI in one group, and then all your reusable stuff somewhere else. All right, so let's talk about streaming architecture a bit. This is from a real app that I've worked in the past. What app is this? What does it do? I have no idea. We've got browsers, categories, engine, helpers, modules, settings, view controllers. I have no idea what that does. What about this one? Who knows, right? So it's just not very helpful. So rather than organizing by technology, organize by domain. It makes a world of difference. So why use all this stuff? Well, it makes it easy to read. Makes it easy to find code. We're constantly trying to find things because we're adding features and fixing bugs. Also, you get cleaner diffs. So one thing that a lot of teams do is they have what's called an Xcode project sorter. The problem is it sorts it alphabetically. It's very arbitrary. So if you've ever worked with the code base, it uses the Xcode sort thing. Yeah, it puts files in weird places that you really wouldn't think, and it's not very intuitive. But if you're encoding all this information into, if you're mapping the way that your UI works into groups, then the sort order already it matters, right? Like it should be the same no matter who's working on what. So you'll get cleaner diffs. Basically, you'll naturally get sorted. You don't even need a tool to sort. And it's also very easy to manage this code. Cool. Another side tip. A lot of times, projects will organize all their code in Xcode using groups, and they won't even bother looking at the file system. And the reason this is an issue is because you might not be in Xcode, right? You might be doing a pull request, you might be in GitHub, you might be looking at the code in Finder, and all that information you just spent all this time encoding is just gone. So side tip, make sure that your group structure syncs with your folder structure on the file system. Cool. So that's building projects. The underlying principle here is make it easy to find code for you and your team. All right, let's dive into a little bit of architecture. So view controllers were designed by Apple to be written as components. And I'll explain that in a second. Component-based software engineering is a reuse-based approach to defining, implementing, and composing loosely coupled independent components into systems. So that's component-based software. This is what Apple says in their view controller programming guide. View controllers are the foundation of your app's internal structure because they play such an important role in your app. View controllers are at the center of almost everything you do, which is very true. So view controllers are kind of important. So we're striving for independent view controllers that are loosely coupled. So what does that mean? How does that play into readable code? Let's look into that. So if you think of this blue box as a view controller, this is the typical life of a view controller. Explodes. It just gets bigger and bigger and bigger, right? There's millions of talks about like how do you make view controller small. So I won't go through that, but a lot of these topics will help with that. So rather than like thinking of view controllers as these really massive things, there's view controller containment, which is very, very nice, very handy. So think of how you can break things down. We'll talk about that here in a second. Again, if you think about view controllers as packages, it really helps with your code because one of the things that makes code hard to read is the scope of things, right? So if you have a variable that's global, right, and you're trying to fix a bug, and you're using this variable, you have no idea where else that variable is being used, right? So if you, I'm going to change the value to this, you have no idea what's happening, right? Like some other view controller in some other far-off galaxy might be expecting that not to change, and then like bad things happen. So thinking of view controllers as like local things that live in their own universe that are their own little package, their own little thing, is really helpful for reading code because you don't have to worry about things that are super like global in scope. Another thing is if we think about view controllers as packages inside of an Xcode group, everything that's inside that little package, that view controller can instantiate and it's fine, no problem. But it's when that view controller starts using things that are outside that where we start coupling. And that's where problems really start happening. And so one really good practice is to inject anything that is outside that little folder into your view controller, so that by looking at the initializer or just by looking at the properties, you can see what this view controller depends on. And I won't go into details of how you do that, but you can Google dependency injection. It's a really, really handy tool. So most of iOS screens are pretty complicated. We're no longer in the world where it's just a table view, right? We've got things that are like scrolling this way, scrolling that way, buttons and crazy stuff, right? And so it's really, really helpful to take a complicated screen and try to think of where are all the independent components, and how can I break that up, and how can I build a container view controller that will contain my children, right? And so for simple things like this, okay, this makes sense, but you can apply it even further. So let's say we've got a table view, like in Twitter, and each table view cell has interactions that the user can take. If you ever try to do this using the delegate pattern, it's terrible because you've got index paths. You're trying to say, oh, the cell from this index path, tap the like button, go do something, and it gets really unwieldy, really, really, really fast. So one thing you can do is each cell can be its own view controller, and so each cell is an independent world where it handles the like button, it handles the retweet button, it handles all these user interactions that are internal to the cell. There's a little bit of boilerplate code that you have to build to kind of reuse your view controller, just the way that you reuse cells, but it's not that bad. We wrote it in about a couple days. So this might be heresy. Oh my gosh, there's view controllers everywhere. They're not that heavy, and they're very, very nice ways to componentize things. So view controller containment is your friend. So why should we use this? Again, it makes things easy to read because we don't have to worry about the scope. Everything's very local to our view controllers. Our view controllers have single responsibility. They do one thing, and they do it very well. And this allows you to be incremental and parallelized. So if you've got a large team and you have multiple people working on a code base, this really helps a lot because all these view controllers are very independent. Now you can say, hey, I'm going to build this one, you're going to build this one, you're going to build this one. You have 5 people all building at the same time, stepping on each other's toes, which is really powerful. Cool. All right, so let's move on to the next topic. This one's really near and dear to my heart because it's helped me and my team so much in the past that I just love talking about it. So let's begin. Use cases. So a use case is a list of actions or event steps, typically defining the interactions between a user and a system. So basically, if you're talking to a user, this is how they describe what they can do inside of your app. So for example, on Twitter, a use case would be log in. Refresh tweet list, create tweet, like a tweet. Very simple vocabulary, stuff that users would understand. So how can we use this? Well, what's interesting is that you can take these use cases and then use the command pattern to actually encode this information inside of your code, and it does some really cool things. This all comes from this book called Object-Oriented Software Engineering, a use case-driven approach. It's a very old book. But it's very interesting. It talks about how it maps the construction industry to the software industry, and how the construction industry is so mature, and how the software industry is so immature, and how we can do things like building components and reusable things to go faster. Super cool. Highly recommend it. It's popularized by Uncle Bob though. So Uncle Bob talks a lot about use case driven development, and he uses that book as a reference to that. So what does that mean? So for us, that means we can use NS operation. So for every use case, we can actually write an NS operation subclass. And it does wonders for you. Makes your view controllers really small. When you're looking at a view controller, you're looking at things that you can understand, like tweet, retweet, tweet, and you create this thing, and then you instantiate it and you run it, and it goes and does its thing. It's really awesome. To learn a lot about NS operation, I'd recommend checking out the concurrency programming guide. It's really good. Highly recommend that document. But so as we're thinking about NS operation and use cases, it's kind of like a recipe, right? If the user wants to take this action, what are all the steps that need to happen to make that work? So let's go through some examples. In NS operation, there's 2 kinds. I'll just briefly touch on this. By default, everything is synchronous, which is very surprising. I recommend reading the programming guide. I'll go in depth as to why this is, but in general, the reason this matters is because a lot of times we're doing network requests, and those network requests are asynchronous. And so if you're writing an asynchronous call inside of an NS operation, bad things will happen unless you use the async version. So highly recommend checking those out. So reviewing the Twitter use cases, right? We've got all these common use cases that a user can do inside the Twitter app. This is what it would look like in Xcode. So we've got use cases, we've got sign up, log in, like, refresh notifications, refresh moments, send direct message. Anyone can read this, right? Like anyone can read this and understand what your app is doing. And that's the whole point of this, right? If anyone can read it, you can read it, I can read it. It just makes life way easier. So what typically goes into a use case in this operation? So a typical use case for refreshing something on iOS, right? You do an HTTP get, you take the data, turn it into models, you persist it, and then you notify so the UI can react, right? These are very common steps that we're all very familiar with. But the idea is to write this recipe inside of an NS operation so that if you ever have to refactor things, you just refactor it inside the NS operation. Your view controller doesn't care because all it's doing is creating an NS operation and letting it run. It's super cool. So view controllers create and schedule use cases. So if you go back to that Twitter example where you have a view controller for each cell, you can think of like we would have 4 different NS operations for each one of those buttons, right? And every time user would have that button, we would create that NS operation, and then we'd run it somehow. We put it on a queue, or we hit start if it's asynchronous, or there's millions of ways of starting them, but it makes it very, very easy to read what's going on with view controller. So why use use cases? If you haven't guessed, every one of these slides always starts with easy to read. That's the whole point of the talk. But also, these things are very reusable. So because they don't link against UIKit, because they're Power Foundation, you can reuse these use cases in a watch app, in a TV app, in a Mac app. As long as you're not doing anything iOS specific, you can take that use case and you can reuse it on another Apple platform. That's super cool. Also very flexible, because you're encoding your requirements of your app in code. And so as long as those requirements don't change, usually our requirements don't change, usually technology changes, and that's what we want to guard ourselves against. So by doing use case driven development, we're able to refactor things much easier without breaking code. And then also, it makes things very testable, because if our use cases are files, NS operations that are that read like things the user does, right? I can easily go and design a test plan where I say the user will do this, the user will do that, and then we'll go here. And what I do is I create these use cases, and I just go one by one. And so when you're reading your test cases, it's super easy because you're just reading what the user's doing, and you're exercising all that logic. It's pretty cool. All right, so that's all the architecture stuff. The underlying principle there is that architecture plays a huge role in how readable your code is. And pick one and stick with it, because I've been in so many code bases where there's like 10 different architectures, because someone new came in and they're like, oh, I like doing it this way, and someone else said, oh, I like doing it this way too, right? And it gets really difficult. All right, on to the third topic, writing code. So this part is probably best just by going through an example, so we're going to do that. All right, so this is some code that I wrote not so far long ago. It's okay. What it does, it's kind of broke. Let me do this. Can't see it on the projector here. So what it does is it handles a keyboard frame change notification, right? If I were to ask you to tell me what this does in 30 seconds, you'd probably be like, I don't really know, right? Like, it's not that readable. It's doing a lot of things. So let's explore how we can improve this. So the very first thing is grabs if statement with a not. That makes it very difficult to read code. So try to use positive conditions. That helps a lot. We'll talk about guard in a second, but guard with negated conditions is just too difficult. Another thing is try not to nest so much. Try to keep it all onto the left. It's possible. We can do it. and we'll go through that here in this example. So here we've got if not transitioning, if left window, and then we got if bottom margin, and blah, blah, blah. It's just really hard. There's just too much nesting going on. But there's one problem. If we want to get rid of all this nesting, this bottom piece that runs a UI view animation has to run always. So I can't really like return early, because if I return early, this never happens, right? So we'll look at how to do that. So this is the code now. That's the change. So let's look at what we did. First thing is we change not transitioning to transitioning, and we're returning early. So returning early is totally fine, totally cool, and actually really awesome. So try to use guard or if to guard your logic inside your method. So that took away one nesting level, which is great. What else did we do? Well, we put the animation in a defer. What the defer does is it basically says you're going to run this no matter what at the end of the method, right? So we're able to put all that stuff at the top where we can read it easily, and we don't have to worry about like if someone accidentally returns early and this doesn't happen. So that's kind of cool. All right, so that's that code. I think we can do a little bit better. There's this silly notification stuff that we're doing top. We're just grabbing user info dictionary and pulling values out. It's not really helping us read the code, right? It's just a bunch of like Cocoa stuff, right? So what can we do? So that's the new code. It's much better. What we did was we created a new type, a struct, called keyboard animation to hold these values. And what we did is we created a failable initializer that will take the notification and will give us a keyboard animation. And the only wrinkle here is that the notification might not have user info dictionary. So what we can do here is we create a failable initializer so that we can do this guard let at the very top. And so if the notification doesn't have the information necessary, we won't create the keyboard animation, and we'll just return early, which is great. So that reads so much better than all that like funky notification stuff. It's just, okay, I'm trying to grab a keyboard animation and instantiating with notification, and if I can't do that, just bail out. All right, so we did that. I think we can still do better. This animation thing is pretty generic. I mean, all it's really doing is calling self.layout if needed, right? And all we're doing here is we're trying to animate alongside the keyboard. And anytime the keyboard animates, we could run this code, right? So this is not very specific to this method that we're writing, right? It's very generic. So what we can do is create a method. We can extend this UI view object. So that's what we did. So we create a new method on the UI view called animate layout alongside keyboard animation. And now all of a sudden, any UI view that I have can do this, which is great. This is what that looks like. It's an extension on UI view. All we literally did was move the code from up there to down there. That's it.
You moved it in the same source file?
Yeah.
Well, how's any other view going to know that it can access that?
Well, I mean, in this case I did, but in general, like Swift will find it, but not other people.
But it's not very readable. You have
Right.
to go back through some.
Yep. So that's why I recommend creating a reusable group, right? And inside the reusable group, I have an infrastructure group, and inside there I have extensions. So that's a great question because that's a great question because we all have these utility classes that are just dumping around for things, right? Which is not a good idea. One good way of doing that is to follow the way that Apple has layered their technology stack. And so if you're extending UIKit, have a UIKit utilities, right? If you're extending Foundation, have a Foundation utilities, right? That's a very easy way to organize your utilities and break them up so that it's not arbitrary where you put them. It's very specific. It's very easy to find stuff. Yeah, thank you. Cool. I think we can still do better though. There's still way too many nested levels. We've got multiple levels here with the left window, which I don't know why we need to grab a window. We've got all this math going on. We've got this comment saying that this must go before, this must go after. We can do better. So all we're doing here is we're updating a constant in a constraint. That's all we're doing, and then we want to animate it. But for some funky, auto layout reason, we have to do this little voodoo magic at the beginning. Then we update the constraint, and then we've got to do this little voodoo magic again. Because we all love autolayout and how awesome it is. But anyway, the point is, like, this could be better, right? It's not very readable. So, boom. That's much better. So what do we do? The very first thing is remove the if statement that was checking for the window and put it at the top as a guard, right? And what that did was it brought our indentation even one level less. And it's very easy to read. So guard and let it for your friends. They're very, very awesome. The other thing we did was we put all that the conditional logic that said this had to be called before, this had to be called after, inside the update compose feedback method. So that cleaned up stuff. I think we can still do better though. Why are we like guard letting window? That's kind of weird. That makes no sense. Like, really, the reason we're guard letting it is because we need to grab it in order to figure out the amount of space between the top of the keyboard and the bottom of the window. That's all we're trying to do, right? And I can't really get that from that. So let's do something better. So we simplify by extending UI window. So what we did is we added a method, Apple style, very long but very specific. Calculate distance from top of keyboard to bottom of window using keyboard animation. So we're using a lot of the things that we're kind of building and make things very easy to read. So what that did was, instead of the window, now we're guard letting the bottom margin, because that's the value that I really want. I really don't care about the window, I care about the bottom margin. Am I able to calculate that? If I'm not, bail out. Right? And remember, we've got that defer that will run my animation anyway, no matter what. So that's kind of cool. So that really helps out reading that. One more thing, I think we can do better. Very top, it's kind of like very innocent notification-y. It's trying to do this weird like grabbing a keyboard animation from notification. We could do that better. So we create a new method called update and animate layout alongside keyboard animation. So we're just passing in keyboard animation straight. So I don't even have to think about innocent notification anymore, right? It's out of sight. And all we did was, in the original method, we're just doing our guardlet, where we're trying to grab the keyboard animation stuff from the notification, and then we're just calling this new method. Much easier to read. And one more thing, there's a self dot that we need to clean. So that's it. That's before. That's after. Which one would you rather read if you're looking at it, right? This is much easier to read. Right? We animate it alongside keyboard, transitioning and return. We can grab the bottom margin, then we just update the constraint, and we're done. Highly recommend this book, Art of Readable Code. It's a fast read. A lot of the concepts from there are what I applied in that example. These are the best practices that we used. We avoided nesting, we returned early, we created new types when we needed to grab information out, and we stayed positive with our conditionals. And the Swifty things that we used were favorable initializers. Guarding is so awesome, highly recommended. But try not to guard not something, because then that gets very, very difficult. If you're in a situation where you're guard not something, just put an if statement and then return. It's very easy. We use defer to do our animation towards the end, and we use optional chaining to do some of the window bottom margin magic. There's a ton of other cool things. I recommend checking out the Swift API design guidelines. Lots of good stuff there. All right. So why use this? Very easy. It's easy to read, right? It's much easier to read this code. One little side tidbit: interface builder is great for so many reasons, but not because of readable. Like, if you've ever tried to manage constraints in an interface builder file, it's just terrible. So some tips and tricks there: try to use stack layouts or stack views. Those are much easier. Or write the constraints in code. It actually is easier to read constraints sometimes in code than it is in an interface builder. So highly recommend that. Cool. So that's writing code. The principle there is writing readable code is super hard, and so it requires time researching and experimenting. Cool. So those are just a few tips and tricks. Where to go from here? All right, I'm gonna put this into practice. Make sure you talk to your team, right? Like the whole point of this, you all have to row together, right? If one person is writing readable code and everyone else is not, it's not really going to make a difference, right? So make sure everyone's on board. Code review. It's really good to be nitpicky at first. Like as you like row together and you're very nitpicky, you're gonna go slow, but eventually you're gonna go really fast because everyone's gonna be writing readable code and everyone's gonna be doing the same thing. So don't be afraid to be nitpicky during code reviews. And then try to automate as much as possible. There's a lot of awesome things that you can do to automate these things. One big thing is if you're going to go and reorganize your entire Xcode project the way we talked about, make sure the team stops working what they're doing, reorganize it, and then start again because it's going to be a nightmare with Git and merging. So the tip there. That's it. So we're all engineers. We all want to build awesome things. We want to do it in a reasonable time so we can enjoy our hobbies, even if that's coding. Benefits are we can deliver faster, right? We read code immediately, we can write code immediately, we can fix stuff immediately. It's a lot more fun to read code and understand what's going on, and just less bugs because everyone can read the code and understands what's going on. So, all happy things. So, shoot for the moon. Our industry is in a point where a lot of engineers are just like, okay, it works, ship it. Don't do that. Like really, like spend the time with your project manager and explain to them because they don't really understand this stuff, right? Like explain to them like this is why readable code matters, right? It's going to save you money in the long run, and that's usually a pretty good argument. Cool. Thank you. And there's some handouts here if you want some of the resources, and that's it.